Okay, everyone, thank you so much for attending the first session and for coming with us to our second session of our Hydronics Technical Training Day. I'm joined with Dave Holdorf. He is the application and product instructor of the East region for Tego Comfort. Also, he's been a past speaker during our previous Hydronics Technical Training Day back in February of last year. And he also will be speaking in our panel discussion, which is happening right after this session. So he's doing double duty. He's putting in, a double shift. So we really appreciate it. I'm going to throw to David in just 1 second, but just for anybody who's attending, if you're having any audio or visual issues, just simply try refreshing the page. That normally kind of fixes any issues we have. Dave is going to answer questions throughout his session. So if you have any questions, just like the previous session, put them in the chat. I'll kind of keep an eye on it. And as soon as questions come up, I will, put my hand up and I'll come back on screen to let Dave know that we have some questions and he'll answer from there. And yeah, so right now I'll turn it over to Dave and we're really excited for this session on domestic hot water recirculation system. So Dave, off to you.
All right. Thanks, Francesco. And thanks everybody for coming in and hanging out today. And I know this was advertised as a hydronics session, right? So throughout the hydronics training day. But I'm going to switch gears just a little bit. I want to talk about domestic hot water recirculation. So kind of the same idea. We still got circulated. We're still moving water around, but I want to talk about recirc because it's I think a part of the industry that everybody knows about, but there's not a lot of them going on out there. And it's a huge opportunity, in my opinion, for a lot of people to gain your services. And but talking about recirc and understanding it and sizing it, really important on what we're doing in there. So there's my contact info. So if you have any questions whatsoever, please don't hesitate to reach out and obviously ask the questions as we go through today. So this is going to be kind of fast paced, just like any other. If you've been to a training class with me before, ask those questions immediately. I don't wait to the end. I want to get those questions to you right away. So as we get started, I want to talk about why recirc. Why do we need to consider adding domestic hot water recirculation systems installed in homes? All right. So it wasn't always that way, and not everybody thinks about having a recirc system installed. So, but as we have to think about history a little bit, and we got to think about home construction and what's happened over the last 50 years when it comes to construction. So, if we want to compare homes from 50 years ago, all right, the average home size in 1970 was 1,500 square feet. Today, it's almost 3,000 square feet. And you think about those size of the homes, also think about the number of people that lived in that house. Okay, that house in 1970, all right, we probably had 6, 7 people living in that house, right? Today's home, 3 to 4 tops. I mean, we can't have kids outnumber parents nowadays. That's insane, right? So with that home in 1970, we never had a chance for water to cool down in the pipes. So it was always there's a line at the door to get into the bathroom in the mornings, right? So obviously, with the home sizes getting bigger, the distance to the furthest fixture has almost tripled. Okay, we're putting fixture groups wherever we want. When you think of that home in 1970, that was a stack system. All right, you had your water heater down in the basement, and you had your kitchen and bathroom that shared a wall right above it. All right, so you were 30 feet, probably less than 5. All right, because it was stacked. You always put that water heater right underneath where the water was needed, and you shared the wall. So very minimal plumbing. Today, we're putting fixtures wherever you want throughout the entire structure. Okay. So obviously, by doing that, we've also doubled the number of hot water fixtures that you have installed in the house today, too. So those doubling of those number of fixtures also increases the demand for domestic hot water. So, for example, even in my own house, I did a renovation 10 years ago. And as I was renovating, and I did a complete gut, new plumbing, new electrical, new heating, new insulation, everything. As I'm replacing the outdoor spigot in the front yard by the driveway, I went and put in a hot cold valve. All right. I wanted the ability to have hot water at the driveway if I wanted to. Because at the time I did have a lab. We loved going out in the hikes in the woods in the mud. And, if anybody's got a lab, you know how dirty they can get some days on a nice hike. So I wanted to be able to hose her down in the driveway if we went on a walk, say today, or wash the truck or whatever, right? So your number of fixtures have doubled. So what does all that mean? Okay, so yeah, it's getting bigger. Okay, but what does that mean to delivering hot water out to your house? So the more fixtures you have, the more volume of water that is needed, especially when it comes to the plumbing codes and when it comes to sizing your pipe. So because you have more volume, you're going with bigger pipe. You think of that home in 1970, all right, it was plumbed in half inch, all right, half inch copper, you're done. Today, we're looking at 3/4 inch and 1 inch, if not more, in some of these projects. Okay, so you got bigger pipe. But then things have changed. All right, so your fixtures and the governments get involved, and we start taking our fixtures and we start doing low flow rate fixtures. You think of that shower head in 1970, that was a 6 gallon a minute flow rate coming out of that shower head. Okay. Today is 2.5, 2.25. There's two coming. Okay. So now that you got this lower flow rate coming out of your fixtures, the velocity of the water has dropped tremendously. Okay. So we got a low velocity and we have an increased distance to get to that furthest fixture. When you do the math and you do the calculations, today, people wait 18 times longer than they did in that home in 1970. All right. 18 times longer. They're waiting for hot water and they just live with it. They just deal with it. They don't do anything about it. They just say, well, that's the way it is. So when you look at it, the average family of four will waste 32 gallons a day waiting for hot water. All right. So I want you guys to think about this for a second. How long do you wait for hot water in your house? Okay. And most people here are going to say maybe a minute, under a minute. You're not sure. You throw out a number. You don't really time it. Nobody's ever really stood there, turned the shower on in the morning, put your hand in the shower, and start hitting a timer. All right, and starting to do that countdown to see what that water, how long it takes to get warm. Most of the time, if you know you have to wait for hot water, what do? You turn the water on. You go do something else. Okay, so it's very easily to waste 32 gallons a day, which equates to about 12,000 gallons a year. And if you want to put that into relationship to something, that's a 10 by 20 pool. And if you want to even put it, even what everybody notices how much water it is, a tractor trailer that you drive by or drive by as you on the highway, that holds about 9,900 gallons. So you're wasting more than a tractor trailer full every year, okay, of water while waiting for hot water. Okay. So whatever the applications, that's what happens. All right. So that's what we think about when it comes to domestic hot water recirculation. So does sizing the pump matter? And I really want to get into sizing today and making sure that we use the right circulator out there. So does it really matter in sizing your circulator? Do you just want to put in whatever you got laying around and, hey, I'm going to move the water there fast? Well, not necessarily. So sizing does become very, very important because when circulators are way oversized, and you may have heard this in some of my circulator sizing classes for heating systems, you don't want to have a big pump. You end up with high velocity. And when you end up with high velocity, you have projects that looks like this. You start experiencing pinhole leaks in copper pipe. All right. Because you have this high velocity, we start eroding the pipe from the inside out. Okay. And that's not what we want to do. And normally it's near elbows. You're going to find those pinhole leaks around elbows and stuff. And that's causing a problem because of that high velocity of the water. Now, okay, we're not using copper for plumbing. We're going after plastic pipes and PEX. All right. Well, not necessarily. That's not impervious. Okay. Yes, PEX does have its advantages, but high velocity also has issues that you can cause on PEX. And now let's start taking a look at hot chlorinated water moving at a high velocity. That starts creating problems in PEX tubing. Okay. So you can see some issues there. So it's not the product's fault. It's the velocity of the water that we're pumping through the system itself. So if I want to give a definition to what recirculation systems are, and I hate reading from slides, but this one is very powerful to me in reading from it. All right. So the definition of a recirc system, a hot water recirculation system, is a plumbing system that replaces hot water to the fixtures without draining and wasting the water. Recirculating systems mechanically moves temperature from a water heater to the fixtures. That's important to think about. It's temperature. It's not a large volume of water. What we want to do is prime the pipes, is really what we're looking to do. We want to make sure that the water doesn't cool down in your plumbing system, okay? And make that hot water available right when you want it, okay? So it's clearly defined in many, many places out there on what we can and cannot do. And so this comes from the Copper Tube Development Association, and you may have seen me talk about this booklet before, this handbook coming out by them, and I talk about it in sizing circulators on the heating side of things. But here we start talking about the velocity that we're going to experience in plumbing systems. So you'll see here in systems where water temperatures routinely exceed 140 degrees, lower flow velocities such as 2 to 3 feet per second should not be exceeded. 2 to 3 feet per second. Okay. So that's important. And we got to keep that velocity down low. Now, this is for recirc. This isn't for your plumbing systems. If you notice in the paragraph right above that, velocities of 8 feet per second for cold and 5 feet per second for hot. Okay. We can easily see 140 degrees get a little bit over in some of our recirc systems, but during your plumbing systems or plumbing draw with your fixtures, those are short spurts. You can handle the higher velocities of those short spurts, but when we're looking at recirc now, different design altogether. And of course, locally aggressive water conditions combined with these two considerations can cause high erosion corrosion if system velocities are too high. Okay, so this is coming right from the Copper Tube Development Association. So here is a chart that we've made, and if anybody wants to get their hands on one, we can easily get it for you. But you really just need to pay attention to this is converting your feet per second into a gallons per minute maximum, not necessarily a target. You should be lower than this, but it's a maximum. So, for example, if you had your smallest pipe, if you're using a recirc line, and we'll talk about designing it in a little bit, your smallest pipe was going to be 1/2 inch copper at 2 feet per second. Your maximum flow rate is going to be 1.6 gallons a minute. 1.6. All right. And keeping that 2 feet per second. If you had 3/4 inch, 3.2 gallons a minute. So we're not looking at very, very high velocity of volumes of water, GPMs here. But let's talk about PEX for a second, right? So PEX, they have their own rules, okay, in what you can do with PEX tubing. So a couple things to pay attention to. Recommended velocity for cold water piping, just for the cold water piping, is 10 feet per second. And if we take a look at the hot, they want to see 8 feet per second. That's what we mean by the draw with the fixtures. All right, not the recirc. They have a separate section on recirc. And now they talk about we want to see 2 feet per second in the PEX world, no more than 140 degrees, and make sure you design it properly. Okay, so those are the important things to pay attention to when we start looking at PEX tubing. Okay. And when we take a look at this, since PEX does have a smaller ID, we do see the flow rates are smaller. Okay, so we're looking at 1.1 at 2 feet per second on 1/2 inch compared to the 1.6 on copper. 3/4 inch is almost a whole gallon a minute less. So, Francesco, any questions that we have out there? How we doing?
We're doing good so far. Haven't been really too many questions coming in right now, so I guess it's kind of a good little promo for if anyone has any questions. By all means, type them away in the chat, and I will read them out for Dave, and he'll answer any questions you guys have. So please make sure you guys are being interactive and also leaving some questions in here for us to answer. I just wanted to quickly, you haven't highlighted any of the polls yet, have you, Dave? Have those come up yet?
No, not yet.
Okay, perfect.
Correct.
Perfect.
Yep.
So exactly. So
Yep.
that's a little good teaser as well too. We have some polls coming as well too later on in the session. So just make sure you guys are being attentive for those as well too. So carry on.
All right. So actually, this is a perfect time to bring one up. So there's a poll that I put up there, and it's called the percentage of homes that have DHW recirc installed. What do you think? Okay. Answer that question. I'd love to know what you think out there, and if you've already attended some of my training classes, maybe you know already. and that's fine.
So for
So
people in the session, it's the second poll that Dave is highlighting, which again, he said the percentage of homes that have DHW recirculation installed. So the options are 25%, 52%, 3%, and then 86%. So if you want to give some of your polls right now, we'll give it a couple seconds and then we will see what the answer is.
beautiful. Okay.
All right. So we're getting some responses. We have some responses for 25%. Majority are saying 3% right now. Then we also have, I think, a couple for 86. None have selected 52%. So we'll give it a little bit of time, and then we'll let you fill us in with what the correct answer is.
All right. Sounds good. All right. So what causes these pinhole leaks that we were just talking about? All right. Like I said, elevated temperatures over 140 degrees or 140 and above. So can easily happen in a plumbing system. Okay. Again, high velocities. Once we exceed those 2 or 3 feet per second, the high velocity is going to start creating other issues as well. And also all the chlorides and chloramines and whatever else is in our water. We don't all live in Maine, right next to Poland Spring, right where the cleanest water in the world's coming out of. So, it's still going to be clean water, but it's still going to have all these chlorides and whatnot in there. So, and constant circulation. All right. Don't want to see these things running continuously. Okay. So that's going to create the issues. So what do we do about that? Well, all we have to do is do some math. All right. We're going to keep calm. We're going to do some math. And if you've ever been to a training class and I did not bring up a math formula, then you weren't in my training class. There's always going to be some little bit of math that we're going to do. And it's nothing hard. All right. It's we got to figure this out. We want to know what you got going on to size the system itself. So let's take a look at this quick example. So on this example, we've got a house. All right. You've got a standard water heater. This is showing a tank style water heater. We got a mixing valve coming out. We got a circulator here. We're feeding out with some 1/2-inch pipe. All right. We got 10 feet coming out. 20, 30 of one. So we got 50 feet of 1 inch. Then we got some 3/4 inch. So we've got 70 feet of 3/4. We got 10 feet of 1/2 inch. All right. And what we're looking for in order to do the math, we need to know about how much pipe and what size is there. Okay. When you are doing this calculation, and now you might take a look at it and say, well, I have no idea. This is an existing home. All right. If you notice my numbers here all end in zeros, you're going to do a quick calculation or quick measurement here. All right. And a lot of times when we see a system plumbed like this, the water heater is going to be on one side of the house. All right. And the pipe is going to run right down the center of the house and we tee off. I don't care about the tees. All right. We just want to know what the trunk line is. So this number should end in a 5 or a 0. All right. You start taking out a tape measure, you're doing it way too long. All right. Quick number here. And then I do want to know what is the dedicated return line and the approximate length of that. And that usually ends up what is the supply all the way out to the furthest fixture. That's the distance and you're done. Okay. Sometimes not because like you see here, it does loop around and whatnot. So that's all I want to see. I just want to see what is the supply pipe out to the furthest fixture. All right. And then what is the return? So one of the things that we did is that we created a design tool to help you do the calculation. And it's a really simple design tool right here. It is an app. You can download it. It is a web app that would show up on your device, or you can hit to our website right away. All right. And this is going to help you do a design for your system. So I'm going to click on, I'm going to show you that design portion. All right. And of course you had to open up on that screen. Let me bring it over here. I was kind of prepped for you. And you come right to the Takeo website here. You'll see a couple of designs. This is for my commercial designers, designing systems out there. And right here, you'll see the DHWR Size Right tool. So we're just going to click on that. New window opens up and you're in your circulator sizing program here. And so the first thing it's going to ask, is there an existing system or will there be a recirc line? And for our application, we're going to hit yes. We're going to choose our water heater. Here we're showing a tank style. Tankless is different designs. And we're going to choose our piping layout. And this one is a trunk and branch with recirc. And you choose the types of pipe. I'm going to leave in copper as our design pipes here. We scroll down a little bit. you come to your supply lines and it asks you what size pipe. We're going to start off with the 1 inch, and we had 50 feet. We had some 3/4 inch at 70 feet, and we had some 1/2 inch at 10 feet. And then we come to the return line, and we add 1/2 inch there, and we type in 80. And once we do that, the program comes online, it does the calculations and figured out everything for you in what your flow and head of the system's supposed to be. Because I put in 1/2 inch tubing here as my copper pipe as my return pipe here, it says my maximum flow rate is going to be 1.6 gallons a minute. It dropped it in there based upon 1.6 gallons. It tells me my head loss of that length of pipe all the way around, all right, at 6.5 foot ahead. And maybe you don't know the install, so you don't know what went in there. You don't know how many valves or fittings or elbows or anything like that. And this is giving you a 40% overage. All right, it's adding some fudge to your calculation. So if you know there's not many fittings in the system itself, so the pressure drop's not going to be higher. Because remember, every elbow you put in has the equivalent pressure drop of 2.5 feet of copper pipe, about that long or so. Okay. And if you have a mixing valve in there, you add that. That also gives you your head loss calculation and adds the pressure drop through the valve. And then we come here and let's say we're going to select our circulators, hit search. And here it's going to give you a couple of different models. But what I really want to show you is how you set up the circulators and making sure how do you get that 1.6? Because there's no flow meters on these things. And I don't want you to put a flow meter in there. All right. So if we go ahead and click on this circulator and you'll see the pump curves, it's going to show you what setting. All right. That's our design point right there. 1.6 gallons a minute at 6.5 foot ahead. All right. You're going to set this circulator up at the medium speed, which is going to be around, say, 20 watts of power. All right. On here. So it comes out of the box on high, which means it's going to be pumping way up here and sending 3 to 4 gallons a minute out to the system. All right. Having high velocity. That's what we want to pay attention to. All right. So you want to keep it low. And you could even go lower if you really wanted to. You really can go lower on here. It doesn't mean much. So if I come back to my design, all right, let me close this for a second. All right. And let's take a look at what's actually going on here at 1.6 gallons a minute. All right. Meaning in 1 minute, 1.6 gallons have moved out of the pipe. And our goal is to take the water that was in our hot pipe, all right, in our hot supply lines that cool down and replace it with hot water, all right, coming from the water heater itself. So how much water's in there? Well, it tells you right here, 4.2 gallons is what's there. That's what's in the pipe. So the total run of pipe there is 4.2 gallons. So I don't need this thing to run very long in order to replace it. Okay. So I could lower this if I really wanted to. Let's say if I put it at 1 gallon. All right. That's why this box is white, allows me to put a different number in there. And if I change it to 1 gallon a minute, it redoes my head loss calculation. All right. Which means in 4.5 minutes, and I just did that to make the math easy here, 4.5 minutes with a circulator running at this speed that gives me 1 gallon a minute, I've replaced all the hot water in that pipe. Okay. So as we come back down, if I hit search, we've got a new design and we click on the pump curve and you'll see here, we're running right there on about 5 watts of power. That's it. All right. In order to recirc this. And that's also another myth to our homeowners out there. They don't want to put a recirc system in there because it's going to consume a lot of electricity. It's like leaving the light on in the basement all the time. Okay. So, we don't want it to use a lot of power here. So if you're using one of the ECM circulators, this is going to keep it really low power. All right. So I want to come back to the question here on that poll. I see the percentage of homes that have recirculation installed is about less than 2%. So those of you that answered 3%, okay, you got kind of close. It's less than 2% of homes out there. Now, I will ask this of everybody out there: how many homes need it? That's the important question. Because most homeowners have no idea this stuff exists. They don't know what exists out there.
And just
Yes,
really
sir.
quickly, we had a question in here from the chat from Vitaly. He asked, why M copper? It is only for closed loop system. Should be K or L copper.
I have those in this options as well. I just left the default so I can move along and keep the time going. So
Yep.
you have the options of choosing PEX and PVC in that program as well. So so that was the only reason why I chose that at all. So you can do the other types of pipe in the app itself. Thank you for the question. Awesome. So I want you to think about that. Less than 2% of homes have recirc out there, but they all need it. Most homeowners don't know this stuff exists. They have no idea that it's out there. Okay. So all your job is to present it to them. You're in their house doing some kind of work on the water heater or whatever. Just let them know. They may not want you to do it then and there because when they see a bill at the end of the day. Okay. You're there to fix something. But if you're draining the pipes or you're draining the air bubbles out of the pipes because you did some work and you're standing there at the kitchen sink and you're waiting for the water to get warm, just say these words. Does it always take this long? I can fix that. Now, it might not mean today, but if you plant the seed, let them know it's not repiping the house, it's putting a circulator in. Maybe it's not, maybe you can't get the return line all the way from the furthest fixture. And I want to come back to that picture for a second that we plumbed in the house. Okay, so I'm going to go back to here and I'm going to go back a few slides. All right, let's come back to here for a second. Now, this is showing the dedicated return line from the furthest fixture. What if you went from here, this point, instead and tied in? All right, before it went upstairs. The problem is not the distance to where that furthest fixture is. The problem is the volume of water that's in this pipe. All right, because we got the 1 inch and 3/4 here. What if you were to drop in a T here, all right, and have your circulator bring that water back? We're recirculating probably 75 to 80% of the water. All right, this is not a very long distance from here to here. Okay, so just things to think about. Bring these options up to your customers. All right, a lot of guys out there are going to assume, well, if I can't get to that furthest fixture, I can't do it. Okay, very, very easily done. All right. Let's see. How am I doing on time? We got 30 minutes left in the class. All right. You guys are the best class I've had all day. So, anyways, so how do you control? How do you control the recirc? And there's a poll out there too. I want to see what the answers are out there. All right. What you got? The best ways to control your recirc pump out there.
You're sorry, Dave. I just wanted to quickly. We had a question as well. It came right after you finished drinking the water, so it's perfect time.
Awesome.
It's from Dean. They asked, "What about demand water? There is an even longer wait."
Yes. Not necessarily. Not necessarily, because your tank style water heater, is storing the energy ready to be used there. But your on-demand water heaters just means, or tankless, right? I prefer the word tankless rather than using on-demand or instantaneous. When they first came out, everybody called them instantaneous water heaters. And then when they installed it in the house and the homeowners went to turn the water on, they're like, well, it's not hot. What's the matter? There's something wrong here. No, there's nothing wrong. It's just instantaneously made back there. We still have to deliver it, right? So your tankless water heaters, the only difference there is that they have a higher pressure drop through the heat exchanger. All right, so we got to make sure we have that pressure drop of the heat exchanger designed in there. And so that may increase your water heater. So if we go back to the design software here, let's close that out. We come back. Whoops, went too far. We come back up to here. Let's start over. Oh, I shouldn't have hit that. Darn it. Well, I could have. All right, that's fine. You come to your tankless water heater, do your pump layout. All right. And as we come down to the bottom here, you need to know your water heater that you're using. What is the pressure drop through that coil? And we're going to put it here. So the manufacturers will show you in a couple of different ways based upon, they might show you foot ahead. They might show you PSI. We show you the conversions right there. So you'll just hit the selection. Here's the PSI and pressure drop, and here it is in foot of head. So it depends on which water heater you're using. And that will give you the additional calculation so you can properly size the circulator out there. So hopefully that answered your question.
And we just have a couple more comments from Greg. They ask speed or CBV valve, and then they also added in VFD drive. So kind of, I don't know if you know exactly what they're relating to there, or if maybe we need a little bit more clarification from there.
Okay. So uh, 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 um, variable, so VFD, I'm looking at smaller residential design here. Could also be used in commercial world, but a VFD drive on a recirc pump, uh, I find is not necessary. All right. That means the pump is way too big. And what I've seen a lot of circulator size for was the total flow rate of the building. And that's not what it is. All right. Now, this software here is doing a residential design. If you have a commercial design, it's a different calculation that we do altogether. What we need to do is figure out what pipe you have, what's the heat loss of the pipe itself, and your delta T that you're working off of. So this is showing smaller ECM variable speed circulators, and this one here, our 006 E3, has a dial on it where you speed it up and down. So you just turn the dial, and that's the speed the circulator runs at. So it goes from a minimum of 4 watts up to 44 watts, or as low as a half a gallon a minute up to 11 gallons a minute is what this circulator does. And that does a lot of projects. Does a lot of projects out there. So I caught the VFD part. I wasn't sure about some of the other comments that was in that question.
So so you've sparked some because we got some good questions coming along. So I'll read them quickly and then we can get back to the presentation. So first off is we have more, so not really a question, but more so a comment from Brian. They say, when we switched from a water tank to tankless, we observed that the water pipes were much colder as there was no steady conduction through the copper lines from the hot tank. So I don't know if maybe you wanted to kind of comment on that, or if that's pretty standard, just kind of with the response from right there.
Okay. So, yeah, because you're getting that conduction of the pipe itself, which is actually more loss, okay, of heat. So, it's always good to insulate the pipes whatsoever. So that's actually detrimental to have the copper pipes warm because it's going to cool down those pipes a lot faster, right? So insulating can actually increase or decrease the amount of wait time. So I always agree and insulate as much as are possible. A lot of plumbing code does call for insulating the cold water pipes because of condensation, especially when you're putting it into walls and ceilings, so we don't have any mold issues whatsoever. But I would go ahead and insulate the hot pipes as well to keep the heat on the inside. It still will lose heat. So, yeah, you get a little bit of that conduction and stacking of the water heater coming out of it. And that's where we start to see those elevated water temperatures in tank style as well, right? So because your temperature sensor in your tank style is about 3/4 of the way down, and that water can stack up, right? So when you go tankless, it's all about efficiency at that point, but not doesn't change much in the delivery of the water itself because the water still cools down in the pipes as you get further away from that water heater itself. So we still want to do some recirc in there. Might be seconds less if you had that stacking in the pipes themselves, but the stacking created other issues like scalding effects and whatnot. So you got to be careful of that as well.
All right, and then the last two comments, kind of back from Greg and Dean, following up with the question that they had beforehand. Greg adds, some pumps have speed selectors on them or CBV circuit balancing valve. And then Dean adds, you have to wait for the pre-purge of the burner as well.
Right. Yep. Okay, I got you. So let me. Okay, I don't. All right. I thought I had a picture of the dial here. I would have to go back and put some numbers back in here. Let me just. We'll come back to this. We had 70. No, we didn't. We had 50 there, so we still stayed the same. We had some 3/4 at 70 feet, and we had some 1/2 inch at 10. My return line of 1/2 inch at 80. Done. Do the math again. All right. Search. And when we take a look at that circulator here, and can pull up the catalog sheet, which gives me a nice big picture. And it gives you some ideas here. So you have minimum, you have a maximum. We have some markings on here showing where our 003 circulator is and 006, which is some of our most common. And what we also show in some parts of the instructions is what does low, medium, and high represent in length of pipe for your system to get you kind of close as well. So we gave you that idea. There is a whole bunch of new recirc pumps that are coming out from Taco in the beginning of 2026. If anybody is going to the AHR show in Las Vegas, you're going to be able to see them there. Some of them do have different markings on the circulator itself showing you your flow rates or 1/2 inch, 3/4, 1 inch pipe that you have as your smallest pipe in the system itself to make sure that one, you're pushing it to the maximum, but you're not going over it. So that's what we have with some of our newer variable speed pumps coming out in the future itself. So excellent questions out there. Balancing valves. Again, residentially, not used too often. I do suggest it if you have multiple return lines coming back to a system itself with one circulator on it. You want to use some balancing valves out there. There's a couple of different manufacturers out there. There's a couple of them also that are doing it thermostatically as well. All right. So they'll open and close based upon the temperature. So this way, it's not over pumping and it's not under pumping either. It's making sure that you have that flow rate. But when you have multiple loops and one pump coming back, that's when you want to use a balancing. If it's a dedicated single loop around, your balancing is the circulator itself. Turn it to where you need it to. So awesome. Let's see, where am I? Here we go. And unfortunately, I started it all the way back at the beginning again. And let's roll here. There we go. All right. So second poll that's there, which actually I think was poll number 1. How do you control this thing? All right. And I see a bunch of answers popping up in here. Awesome. Okay. So, and obviously I gave you 90% of the answers on how it's controlled, right? So 24/7, I don't recommend that residentially. All right. It doesn't even need it commercially. All right. The only time I see 24/7 is maybe a hotel. All right. Or an apartment complex. Do you run the pump 24/7? Okay. So again, that becomes a tremendous waste of energy, not just electrical consumption, but also that pipe's running throughout the entire house ends up being a radiator and constantly giving off heat. Okay. So, but it's done often. I see it often, right? We can add an aquastat. Okay. So if you add an aquastat on there, and we typically put it on the return line right near the circulator. And if the water gets warm at that point, it says, hey, we're hot. That means the whole system's charged. Let's shut off. And I see a good chunk of people said, yeah, we're going to use it by aquastat. The downside is the aquastat shouldn't be where the pump is. The aquastat needs to be where the last fixture is in the house. All right. So it needs to be 80 feet away. Ideally is where the aquastat should be. Okay. Now we can go ahead and throw timers on here. Okay. And timers is a good idea because people use water on a schedule. All right. You have a few hours in the morning, a few hours in the evening in a residential setting. In a commercial structure, if an office building is looking for adding recirc in there, well, you only need it during working hours. When nobody's there in the building, shut this thing off. No one needs it anymore. Turn that radiator off, so to speak, and turn the pump off. Okay. And you can do a combination of the two as well. So you can do a combination of the aquastat and a timer together. So again, trying to keep that pump down low, right? Because we want to watch for that velocity. All right. And we also want to make sure that we're not constantly running that water through, creating those pinhole leaks in copper pipe. Now, there's another way that I like to talk about, and I want to compare it to the Nest thermostat for a second. And why do homeowners and people love doing Wi-Fi style thermostats out there? All right. What is the biggest allure to these types of thermostats? I mean, I've got 3 of them in my house. All right. I got one controlling my air conditioning and another 2 doing some radiant floor heating in the house. Well, why does everybody want these things? Okay. And I'm going to assume right now, 90% of the people out there, what you're thinking in your head is so I can play with it on my phone, right? Homeowners, they want to do this with it all the time and they want to see it online. They want to see it on their phone. They want to make their adjustments and settings. All right. And actually, that's pretty far from the truth. And I've seen a lot of the data out there. And what happens when one of these thermostats gets installed in somebody's home, the first 3-4 months, They're looking at it all the time on their phone. They're like, "Oh, this is cool. Look at the temperature in the house right now, and maybe I should change the temperature. And let me mess around with the family members that are still home at the house, and I'm going to turn the air conditioning on, and when it's cold outside, and everybody freak out what's going on, and just because we can, right? The number one reason, the number one reason why these things get installed in the house, yes, is for economy of operation. All right, they want to drop their fuel consumption, but what they're also looking for is to program itself. How many people have programmable thermostats installed in their home that are not programmed? Or if it is, who programs it? Okay, so that's why they like these things because they program themselves. They've got motion sensors, especially when it comes to your air conditioning, your forced air systems. As soon as I walk in the house, turns on. Or some of them have geocaching, right? So they recognize where you are with your phone, how close you are to home. Hey, I'm going to turn the air conditioning or the heating on before you get home. I know you're getting close, within a 10-mile or 5-mile radius. It all depends. So that's what we see going on when it comes to heating and air conditioning, right? They like these things because of what it can do. Well, we have something very similar out there. We call it the smart plug. What this does is learn when people use hot water in the house. All right. And it runs the circulator just for those time periods. And the way it does it, it uses a sensor, all right, temperature sensor. We're not looking for temperature, but what it's looking for is a vent. And it says, hey, that's when water was used. And if you don't have a schedule, all right, then this thing just puts a circulator in a pulse mode, all right, an on off operation, so to speak. Run 5 minutes on, keep 10 minutes off. It's not going to cool down that fast. Okay. So, for example, this is what we're looking at when it comes to learning. So let's say this is your house. You turn the system on. It's got a 7-day calendar built in, and it's always thirsty for knowledge, and it's always going to try to learn your schedule, and especially changes that happen. So let's say Monday morning and Tuesday, 7 o'clock, about 7 o'clock in the morning. Usage, all right, and it records it, and then it says, all right, well, there was nothing after 8 o'clock in the morning. So from 8 o'clock, okay, all the way down to say noon, there was no water usage in the house. And then all of a sudden, about 1 o'clock in the afternoon, there was some laundry done on both those days. Okay. Records that as an event. All right. Now we get down between 2 and 5 o'clock, water wasn't used. All right. Now you got baths for the kids that goes on for a couple hours. All right. And then from 8 o'clock on, there hasn't been any water usage. All right. So what this does is it says, hey, we're going to make sure we'll run the circulator for the occupants. Okay. And we're going to give you a window of opportunity. And it was based upon the length of use of that water. So we know not everybody gets in the shower exactly 7 a.m. It might be a little before, might be a little bit after, but what it's going to do is turn on a little bit before and stay on for a little bit after. All right. Depending upon how long that event was. And during this on event, it cycles the circulator 5 minutes on, 10 minutes off. 5 minutes on, 10 minutes off to make sure one, we keep the power consumption down low, and two, the water's not going to cool down that fast. Then it keeps it off all day. All right. And then it keeps it off all night long. Now we don't have that radiator constantly giving off heat in the house if we had left it running 24/7. We don't have it still radiating if we put it on an aquastat. Now, it's not bad on a timer, but again, who programs the timer? So when I'm looking at our polls here, we had a very small percentage say, hey, 24/7. We had the aquastat, we had the timer. They're probably neck and neck, and the aquastat and timer tied together was by far the best. So now we're taking timer, aquastat, and self-learning, okay, in your system itself. And let's say your Wednesday, as the smart plug is learning your events in the house, there's no water usage in the middle of the day on Wednesday. Well, it doesn't run then. All right. And it just keeps the pump off. So here we're looking at per day of maybe a 20-minute runtime, 30 minutes of power. And because we have that 006 on there, turn it way down. So you've got 30 minutes of runtime at 8 watts, 10 watts of power. So really keeping the power consumption down low. Okay. So eliminate the resistance to adding recirc into a house. All right. Always let it learn. Because I've talked to a lot of contractors and putting timers in there and says who programs it. And the downside to timers is that they're electrically powered. which means if you have a power outage, they lose the programming, meaning they don't know what time it is anymore. And of course, twice a year, without fail, we see daylight savings come through, and that throws off the timers. And a lot of the timers have a manual override, which are then powered on to run 24/7 because a homeowner hated paying that bill when they asked you to come out and take a look at it and say, okay, well, I got up this morning, I went to take my shower, and I had no hot water, but there was hot water in the evening. Well, that's because on Sunday or Saturday, we had a power outage for 2 hours. All right. Storm came whipping through, and we threw everything off by 2 hours on a regular timer. This is going to relearn that schedule as well. All right. It also has vacation mode, meaning if nobody's home for 36 hours, no water usage, it goes in the off mode until somebody turns it back on again. It also has the option in projects where you don't need to have it learn anything. You have a commercial project, an apartment complex, a hotel, whatever, where you put it in pulse mode, which means it runs 5 on, 10 off all day, all night. All right. Again, not 24/7, but you have those applications where that happens. So, especially when we think back, 5.5 years ago when everybody got locked down in their house, all right, there was no more schedules for showering anymore and using hot water. So I had one of these in my house. I hit mine into the pulse mode. So we all had hot water whenever we needed it. So just things to think about. So I talked about tank style and we quickly talked about tankless systems out there, but we also, now we want to try to keep this efficiency as low as possible as well. I mean, as high as possible. We want to use the least amount of power. And here, this is a system that is using a circulator that goes underneath the sink now, rather than a dedicated return line. What this is showing is a retrofit application in your tankless world. And there's a lot of options out there, and I had to focus on what we could get done in the time period. So this is your retrofit. So not a dedicated return line, but now we're going to use the cold water supply as a return. All right. And this is probably the most efficient system out there. It is a larger circulator, but it runs on command, meaning when it gets operated by the homeowner. All right. The homeowner turns this on. So it's not learning a schedule. What it does is says, hey, I need water and I want it now. So what it does is it turns the circulator on based upon either one, a motion sensor. You walk into the bathroom. Hey, there's a demand for hot water. I'm going to turn on. All right. Hopefully, someone's going to use that water in the next couple of seconds. Um, or you have a push button on here. So if you have a high traffic area and you don't want to use a motion sensor, we have a push button that says, hey, we're going to get activated here. I'm going to use hot water right now. So, like I said, this is going to get mounted underneath the sink. We could do back at the water heater itself. And if you do have that dedicated return line, like I showed earlier, you can do that as well. But this is also showing you the retrofit applications. All right. And like I said, we can design, and this is designed for tankless because your tankless water heaters have going. So here you can see the under sink installation. All right. And we're showing it with tank and tankless. So either water heater here. And you can put multiple sensors in one house and multiple buttons in the house and a combination of the two. And so what this does is it's not looking at temperature, it's looking at activation. And as soon as, let's say, you walk into a room and the motion sensor or you hit the button sensor on the controller, it says, oh, I got a need for hot water. First thing it does is it takes a look at the temperature. Does have a temperature sensor built into the circulator, and it says, all right, what's my temperature here? If it's below 99 degrees, I'll allow to turn on. So if what we've got is room temperature water here on the hot water supply, it has cooled down to 70s. Nobody's used it for quite a few hours. The water temperature on the cold water supply is also 70 degrees. So they're both room temperature right now. And so what the active is, all right, let's assume everything here is 70 degrees. We're going to turn that pump on and we're going to achieve an 8-degree rise. And into the control an 8-degree or a 15-degree rise, your choice. 8 degree is usually more than enough. So you do the 8-degree rise, which means as soon as the water here in this pipe gets to 78 degrees, we're going to shut the pump off, which usually means 10 to 15 seconds, maybe up to 40 seconds of runtime is what we're looking for here. And we took that 70-degree water here and we moved it down the cold water supply back to the water heater to get heated up again. So we're not wasting it. We're not sending hot water to the cold side. That's important. We're sending room temperature water over to the cold side, which was already room temperature. And as soon as we get to 78 here, turn the circulator off. Right behind it is going to be your 120 coming out of the water heater and activated. So yes, you could put this underneath the fixture. Now that picture that I showed you showed it mounted to the floor underneath the vanity. It could go also up against the back wall. It does have a rubber mounting plate, so this way you don't see any vibration happening. And it is probably the most efficient because again, the circular only runs 15 to 40 seconds at a time. All right. The motion sensors have 4-minute lockouts, and the temperature sensor also looks at, hey, I need to be below 99 degrees before I turn back on again. Okay. So, like I said, very, very quick, fast, efficient method. And if you put it at the furthest fixture, all right, you'll get everybody else along the line will have that recirc as well. Now, again, I know that the furthest fixture away, if it's the master suite, really hard to find that real estate or necessarily finding an outlet underneath the vanity. Well, one, you got an outlet probably right above it. All right, so we can bring it down the wall. All right, behind the wall and put a pigtail on it. Or maybe you use the kitchen. All right, you got the kitchen sink where there's an outlet already going to be underneath there for either the disposer or for the washing machine. We could put it there as long as the kitchen's not the first fixture on the line. Maybe it's the second or third down the line. Then I would do that because, again, you're recircling everything throughout the whole loop. So just things to think about, and just present it to your homeowners that you have an option for hot water recirc in your house. And here I show it with the dedicated return line as well. So how we doing out there, people? All right, I have hit the end, and I think I gave us a little bit of extra time back at the end to throw up any other questions that we have.
Perfect. Yeah. So we had just one comment made from Brian. This was kind of right after we summed up all the questions that we kind of were going through. He added in this comment, so I wanted to save it till the end just because we answered quite a few questions. So we wanted to get to some of the slides. But Brian says, best practice to curtail recirculation pump operation when returning temperature is dedicated hot for long enough that longest loop had time to return its cooled off water.
Okay.
Yeah, I know. It's this message was a little bit before.
More of a comment.
Yeah, it was from before, so I wonder if maybe.
Okay. So. All right. So I think it was a comment or an answer to one of the questions that I presented up there. So excellent. Awesome.
Yeah.
All right.
Just waiting. I know some people are commenting about some it's buffering, the audio and the video. So we appreciate you guys. We know when you're streaming kind of this type of through a software like this, when we have presentations going as well too, when we're sharing screens, there is that chance of buffering happening. So we appreciate you guys working through as well too. If anything as well too, the video recording of this session will be posted on our YouTube page as well too, so anybody can watch it afterwards as well. And then, like our usual technical training days, these presentations get turned into written articles that will be featured in the next edition of our magazine. So this presentation will live on as well too. So hopefully throughout the YouTube page, when we watch the video back, maybe the buffering won't be as much of an issue in that one as well too. But we'll just hang out for a couple more minutes, see if we have any additional questions. Brian adds, the speaker covered very well and even more advanced with smart plug, which looks awesome.
Thank you. Thank you. It's one of those things that not a lot of people know about. Again, recirc, like I said, I feel is one of those instances where you can be a hero to a customer. So I'll give you a little story. So I've been with Taco now 13 years. And when I first started here at Taco, my kids were younger and my wife was very active in their lives. She's class mom, PTA, Girl Scouts, you name it. She was involved in a lot of different aspects of my kids' lives. And so I ended up having lots of meetings at my kitchen table, which meant when I came walking in the door, and I travel a lot. So if I came walking in the door wearing a shirt like this and it said Taco on it, people look at it and say Taco Bell, but it doesn't look like the Taco Bell logo. And they're all confused, right? So they would ask me what I did. All right. And yes, I do a lot of hydronic heating. I did radiant floor heating in a past life, stuff like that. But also I do the plumbing here as well. And I wouldn't talk about the heating stuff. I would talk about hot water recirc. And they're like, "Ooh, what's that?" And I would explain it to them and I talk about it and bring it up to them. And they're like, "Oh my God, that's amazing. I would love to do something like that in my house." And what do you think the next question always was? All right. And you can answer it, Francisco.
How much?
How much? Right? Always how much? And I would tell the ladies there, and I said, "I don't know. It depends on your house and your water heater and what you've got going on." And I would say something anywhere between $500 and $1,200. I don't know. All right. We'd have to analyze it and take a look at it. And guess what they said after the time? Guess what they said?
They're probably like,
"That's it."
you're like, yeah, expensive or
That's
not
it.
bad, but not bad.
All right. You don't, the point of the story is you don't know your customer. All right. So my brother was doing a renovation on his house and he added a second floor to it. And as the construction was happening, I said, "Hey, make sure you tell me when the electricians are and before the sheetrockers show up so I can run some return lines. I want to get out of everybody's way. I want to run a return line to your house because the house, when you're adding a second floor to a house, the plumbing was a nightmare. They tried to keep as much as they can, on the supply lines everywhere. And so I'm like, yeah, I'm going to run a dedicated return line. Well, it never happened. My brother never installed it. He says, yeah, he came up with every excuse in the book of saying, well, it's like leaving a light on in the basement. It's too much energy. It's too much electricity, blah, 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 blah. And I'm like, do you have any idea what I do, dude? Right? None. So anyways, the house gets done and doesn't have it in the house. So we're sitting there talking to at the house one day, and my sister-in-law says, I wait 6 minutes for hot water. And my brother turns around and says, "No way." He's like, "If anything, I wait like 20 seconds for hot water." She's like, "Yeah, I'm first one in." Right. And then I told her about it, and we did retrofit and we added recirc into the house later on. And she looked at him right away and says, "Are you kidding me? Really? That we didn't put it in there because you thought this?" And when I did the calculations and I told them how much money electrically it would cost to run the pump in their house, it came to $7 a year. A year, not month, year. Okay. So, yeah. Give that opportunity. Let them make that decision. You don't know their pain points. If they want to give you money, you should take it. Okay. Excellent.
Perfect. And I guess, yeah, we just have a minute left. And I know Dave is going to be participating in our panel afterwards. So I guess did you want to highlight maybe any, I know obviously, like you mentioned, you do a lot of training with Takeo. Do you want to mention any training that's coming up as well too, that you like to promote through Takeo that you'll be, taking part of, or any additional things that's going on with Takeo that you'd like to highlight at this point?
Pay attention to 2026. A lot of new circulators coming out. Actually, I do have another training tonight called Takeo After Dark. So if anybody's been to a Takeo After Dark episode, we actually have it's a training / podcast going on. We have Leslie McGlennon, the pipe wench from BC, joining us tonight as our guest. And we're going to be talking about zoning systems, zoning by zone valves or zone by circ, which way is better. So that is, take a look at our website. All right. We have our own tab called At Training, but we're also going to be streaming it on Facebook, YouTube, and LinkedIn at the same time. So follow the Takeo page at 7 p.m. Eastern. That'll be tonight. And right now, since we're running into heating season, we kind of slow down in the training world.
Right.
So
perfect. So yeah, but also like we said, Dave is going to be in our next session right now with the panel as well too. So he's not gone yet. You'll have him for a little bit longer as well too. And if you are really interested, again, like you said, he has the Takeo After Dark that's happening tonight as well too. So we appreciate everyone for sticking with us through this session, and we'll see everybody in the next session for the panel discussion on integrating smart hydronics. Thank you, guys.